Python's for loop is an exceptionally powerful construct that'll help you iterate over sequences of elements, making it a cornerstone of most programming tasks you can imagine. Whether you are working to refine an app, tinkering with data, or just practicing for an interview, understanding the nuances of Python's for loop is essential. Let me walk you through the fundamentals of for loop, covering everything from its unique syntax to its different applications, all woven within the conversational fabric of our discourse. In Python, for loops operate on the simple principle of repeating a block of code for each item in a sequence. Essentially, a for loop can iterate over any sequence like a list, a tuple, a dictionary, or even a string, providing flexibility for various programming needs. Think of a for loop like being on a mission, where each iteration corresponds to exploring a different element in the sequence. As the loop progresses, Python assigns the current element of the sequence to a variable and executes the code block within the loop using that variable. After that code block finishes executing, the loop moves to the next element, which, in essence, is the start of a fresh iteration until the items in the sequence are exhausted. The syntax of a for loop in Python is rather straightforward. Here's an example to illustrate Python for item in sequence, #execute code block. As you can deduce, the code block runs until every item in the sequence has been covered. And remember, the for loop does not mandatorily require an index variable. However, if, for whatever reason, you need to track indices alongside items, consider using the built-in enumerate function. It hands you both the index and element right in the hand. Safety aside, Python for loops are designed to provide clarity and easy readability, so they're pretty great for novice programmers as well as seasoned pros. However, the real charm lies in their versatility. They can iterate not just over sequences, but also non-itable objects. This is possible by boxing the non-itables like numbers inside a list. A subtle hint here: for better Python etiquette, consider using list comprehensions or generator expressions whenever you are required to process non-iterators. Moving to the realm of performance, for loops can be a mixed bag. While it's typically fine to use for loops for iterating over short lists, performance considerations come into play for larger lists. Python internally uses something called a C loop under the hood for most for loops, which is considerably powerful and efficient. Nevertheless, using an explicit list can impact memory if you are dealing with large lists, as Python has to store all elements in the list in memory before the for loop starts. In such cases, consider using generators, which yield values one at a time and consume less memory. There's a handy concept called else associated with loops in Python, which may seem misleading at first. In Python, the else block after the for loop executes only when the loop has completed its course. So, in practical terms, this means executing extra code after the for loop only when the sequence has been fully traversed without any break in the loop. Remember though, when break statements are involved, this else block gets bypassed, so use this feature judiciously. Lastly, be a keen observer in your coding journey. Look for opportunities where a for loop can simplify repetitive tasks or handle complex sequences and apply these principles consistently. As you grow more comfortable with for loop, you'll find yourself writing cleaner and more efficient Python code that is both easier to read and more maintainable. Now, with these insights firmly in hand, go ahead and create some Python magic with for loops while honing new skills. After all, practice makes perfect. But remember, learning never stops, so always keep exploring. Check out more coding challenges and projects on Neeraj's blog at neeraj.qzz.io and subscribe to TechLab for some more Python tutorials.